Section 11.1, Day 1, Permutations and Combinations. Please write down the essential question. How do I solve problems using permutations and combinations? So you have previously used tree diagrams to find the number of possible combinations of a group of objects. In this lesson, we're going to use the fundamental counting principle, and this is what it is. If there are n items and m1 ways to choose a first item, m2 ways to choose a second item, and so forth, then to find the total number of ways that we can choose a certain item, we will multiply them all together. For example, let's do example 1. To make a yogurt parfait, you choose one flavor of yogurt, one fruit topping, and one nut topping. How many parfait choices are there? Well, when we look at this, to figure out how many parfait choices are there, we can see, let me get my pen out here. There are 2 flavors of yogurt. There are 5 fruits, and we're timesing these. And there are 3 different nuts. To find our total possible choices, 2 times 5 times 3 is 30. We just use the fundamental counting principle. Example 2. A password for a site consists of 4 digits followed by 2 letters. The letters A and Z are not used, and each digit or letter may be used more than once. How many unique passwords are possible? When we talk about digits go from 0 to 9. Single digits. How many are there? There are 10 of them if we include 0. So there are 10 possible digits to choose from for this unique password. And another 10 because it says each, I'm going to highlight something, each digit or letter may be used more than once. So then another 10, another 10. So the first 4 parts of this password are digits. Letters, when we talk about the letters in the alphabet, but we're excluding A and Z, there are 24 letters because there's 26 letters in the alphabet. And it says A and Z are not used. When we multiply all those together, we get this. That is how many unique passwords are possible using 4 digits and 2 letters, excluding the letters A and Z. Example 3, a make your own adventure story lets you choose 6 starting points, gives 4 plot choices, and then has 5 possible endings. How many adventures are there? Well, we have 6 starting points, we have 4 plot choices, and we have 5 possible endings. So how many adventures are there? 6 times 4 times 5 is 120. Example 4. A password is 4 letters followed by 1 digit. Uppercase letters A and lowercase letters a may be used and are considered different. How many passwords are possible? Okay, so let's see here. A password is 4 letters, so let's think about this. We have 4 letters. Letter, 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 followed by digit. Okay, it should say digit. It's not going to let me get my marker way over there, but that's all right. Okay, so now, I think what I'm going to do though, I have to fix that because that is going to bother me. I'm sorry, everyone. Just bear with me. Let's try it again. going to move way over. Letter, 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 letter. Yay, got it. Okay. So if we're talking about uppercase and lowercase, that means there's 26 uppercase, there's 26 lowercase, there's 42 letters in the alphabet. It doesn't say that we can't use them more than once, so we assume we can. So 52 times 52 times 52 times 52, and the digits are 0 to 9. Multiplying all those together, that is how many passwords are possible using 4 letters, using uppercase and lowercase, and 1 digit. I'm going to move on, but obviously, since it's a video, you can pause at any time. A permutation is a selection of a group of objects in which order is important. So I'm going to do an example in class to talk about that. Combination is a grouping of objects in which order does not matter. That's important to remember that. Now let's talk about this thing called a factorial. The factorial of a number is the product of the natural numbers less than or equal to the number. 0 factorial is defined as 1. So for example, if I said, what's 4 factorial? You would tell me that's 4 times 3 times 2 times 1. That's what that means. Permutations, the number of permutations of 7 items taken 3 at a time. We use this formula right here. The number of permutations of n items taken r at a time is, so right here. This is the formula that we are going to need to remember, because we're going to find the probabilities of items and find out how many possible permutations there are, and we will have to use this formula. We have a total of n taken r at a time. N is always bigger than r. All right. Sometimes you may not want to order an entire set of items. Suppose that you want to select and order 3 people from a group of 7. One way to find possible permutations is to use the fundamental counting principle. So if we're dealing with 7 people and you are choosing 3 of them in order, that means when you talk about in order, we can talk about the fundamental counting principle. There are 7 choices for the first person. Once we pick that person, then there's only 6 people left, and then there's only 5 people left. There are 210 permutations when we have 7 people and we're choosing 3 of them in order. We can generalize this as a formula, which is useful when we're dealing with large numbers. But when you're dealing with small numbers, sometimes we'll just use the fundamental counting principle instead. So example 5. How many ways can a student government select a president, a vice president, a secretary, and a treasurer from a group of 6 people? So what we're going to work on in class is understanding when order matters and when order does not matter. And once we learn more about combinations, which is in the second video, the day 2 video, we can talk about that more. Whenever we're talking about how many ways can a student government select a president, vice president, secretary, and so forth, or how many ways can we select a captain and a assistant captain and a manager, or how many ways can we select first, second, third place? All those, only one person can have that role, so therefore order is going to matter. So on this example, order matters, and when order matters, it's called a permutation. You want to get in the habit of remembering that. So we're talking about picking a president, a vice president, a secretary, and a treasurer. And we're starting with 6 people. Well, there are 6 people to choose from for a president. Once we pick the president, there's 5 for the vice president, 4 for the secretary, 3 for the treasurer. 6 times 5 times 4 times 3 is 360. We just used the fundamental counting principle. Well, let's say we wanted to use a formula. And sure. Yeah. Okay. So we have n factorial over n minus r factorial. We recognize that it's a permutation. All right. We have 6 people and we are selecting 4 government positions: president, vice president, secretary, treasurer. So that's what that is. So then we have n factorial all over n minus r factorial. Well, that's 6 factorial over 2 factorial. And when we write that out, 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, and 2 factorial is 2 times 1. That cancels with that, and I'm going to extend the page here. And we get 6 times 5 times 4 times 3, which we already said was 360. So we solve this problem 2 different ways. You don't have to do that, but in class I'm going to demonstrate how to do that. One way we use the permutation formula, and the first way up here, we used the fundamental counting principle. We're going to do 6, 7, and 8 in class, and here are your video questions.